Good morning, good morning. All right. There is a warm-up for you to try, so if you'll go ahead and pause your video, take a minute, try this, and then check in and see how you did. All right, go ahead and hit pause. All right, thank you for hitting pause. If you haven't, do it now. I'm about to write some answers up. All right, midline, y equals -2, right? Our amplitude is 3. The max and min, we're going to go from the midline. Let's see, I need to go from -pi to pi over 2. Okay, so I've got more on the left than I have on the right, so I'm just going to go like that. I need midline at -2. 1, 2. This is my midline. All right, and from there, I'm going to go above and below 3 units. 1, 2, 3. So that actually is just 1 above 0, right? This is -2, and then 1, 2, 3. -5. All right, so max and min, very highest we're going to go is 1. And, oh, sorry, max is 1 and min is -5. All right. We have done this lots of times, so I'm hoping that all of that was pretty clear and you were comfortable with that. This is the part where it gets a little more exciting. So we've labeled our y scalar, f of x scale, and we need to label our x-axis. Or in this case, well, here it says x, here it says theta. You know, theta is an angle measure, x is an independent variable. In this situation, we're talking about the same thing here. Okay, so we want to start at -pi and end at pi over 2. So I know if I go all the way to the left of my graph, I'm going to have -pi. Halfway is -pi over 2. And then here I'm going to say it's about the same distance. I'm going to measure +pi over 2. Okay, so I've just I know I'm going to start here and end here. That's all I want to see of this graph. But I need to figure out the period, so I'm not sure why that's not written, but let's write it. And I want to find out what we're calling the scale. All right, and maybe that's not the best word for it, but it's what we're going to call it. Okay, so the period, what we're going to do since we're talking about radians, we're going to say 2 pi divided by our b, and b is this variable right here. So that's changing our wavelength. It's a horizontal compression or a dilation. Okay, so we have pi over 2 divided by 8 is 1/4. So pi over 4 is 1 full period. Wow, okay. So pi over 4 would be halfway between 0 and pi over 2. So this is pi over 4. So we're going to have 1 full period here, 1 full period here, and then if I go backwards, we're going to have -pi over 4, -1 pi over 4, 2 pi over 4, 3 pi over 4, -3 pi over 4. Okay, so technically our scale should be 1/4 the size of that period. So to find the scale, we're going to take the period and we're going to divide it by 4. All right, and that's the same thing as taking the period and multiplying by 1/4. It's the same thing as dividing by 4. So I end up with pi over 16. Okay, this is a lot to label. I'm not sure I'm going to have enough space here to label it all. So I'm going to cut that in half and half and half. And half and half and half. Right? So this distance here should have been equal to that distance there. It's not exactly, so I'm not completely happy with my spacing. All right, cut in half and half and half. Half. All right, so we're chopping that one period into 4 sections. I've asked this question a million times. Why 4 sections? Because there are 4 quadrants. All right, and we're plotting our quadrantal angles. All right. So we could label them. I feel like I don't have enough space, but I'm just gonna count by 16ths. So 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16, 5 pi over 16. I would just keep going. 6 pi over 16. I'm just counting in pi over 16ths. Right, so 1 pi over 16 is going to be here. 2 pi over 16 simplifies to pi over 8. That's what I would put here. 3 pi over 16 goes here. And 4 pi over 16 simplifies and just becomes pi over 4. Each of these tick marks represents one more pi over 16. So 4 pi over 16, 5 pi over 16, 6 pi over 16, 7 pi over 16, 8 pi over 16, and 8 pi over 16 simplifies to pi over 2. So that what I call the scale, or the step, maybe some people call it the step, and maybe there's a better word for it, but it's basically what we're counting by, right? Then we're going to go negative pi over 16, negative pi over 8, negative 3 pi over 16. So we're just doing the same thing, but we're counting backwards. Okay, so I am just going to label that much just because it's going to get too messy. But I know we're graphing a sine curve. So we know sine at 0, sine is at the midline. So I'm going to start here at 0. I know it goes up to the max as long as it's, oh, whoa, whoa. This is a very, right, okay. So here, my first tick mark, see I went right to the labeled one, but I was supposed to label all these. Okay, so here, up to the max, to the midline, to the min, to the midline. Back up to the max, midline, min, midline. All right, let's graph this real quick. Just gotta have sound effects. Okay, cool. All right, so like I said, this pi over 4 and this pi over 4 were different sizes, so I'm unhappy with that. But we are going to just continue that pattern here, back here, up to the max, to the midline. So we're going to continue that down until we get to negative pi. Wow. Okay. Do we know we were asking you so much? Whew. That's a lot. All right. So if this, I'm going to pause and do this so it doesn't take up so much time on the video. All right. So that would be our completed graph. Whew. From negative pi to pi over 2. All right. So today what we were supposed to be doing was taking a quiz, but we decided to bump that till tomorrow. So those of you watching this video, so quiz tomorrow is Thursday. 3:15. Today is Pi Day. Happy Pi Day if you're watching this on the 14th. We are having our progress check coming up on Monday. So we need to start looking back and making sure we're comfortable and refreshing our memory on what we were doing before we were doing trig functions. All right, so here are some homework answers. If you want to pause and look at that more carefully, feel free to. Same process, 2 pi divided by 4 times 1/4 to get my scale, count by pi over 8. It's 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Right, so I counted down here, but then I simplified and put them on my scale. All right. Some of my students have been trying to use this as their midline. I'd like you to be careful to always label that 0 and then move your midline and not just labeling that line -2. Okay. All right. So this is our tangent function from negative pi over 2 to 3 pi over 2. All right, and then this one from negative 8 pi to positive 8 pi. It turned out our period was 8 pi, so we just had to do 2 full cycles. One, yeah, okay. So if you have questions about the homework, feel free to ask me. But let's go back and review some of the stuff that we did in the past. All right, here it says the following coordinates lie on the terminal side. This point lies on the terminal side of angle theta. Okay, so let's think of this. So we're talking about an angle starting, initial ray starting here, terminal ray is going to land at 3, -7. So if I go +3, -7, my terminal ray is here. My initial ray is here. So we could think of this as a negative angle or a positive angle, but theta, we're going to say in standard position is a positive angle. All right. Determine sine, cosine, and tangent of theta and the measure of the positive angle. All right. So it specifies I need to find the positive angle. Round the angles to 3 decimal places. All right. So I actually know a lot of information, right? 3, -7, if I make my right triangle, a little reference triangle, I can see, okay, well, I moved 3 to the right, right? That's my x value. I moved 7 down. And now we need to find that hypotenuse, right? So 3 squared plus -7 squared equals, well, let's say the radius squared. Or you could say hypotenuse or c or whatever value you're comfortable with. All right, 9 plus 49 equals r squared. So that's what, 58? And square root. So r equals the square root of 58. Okay. So we found the radius by using Pythagorean theorem. Now, so this is our theta. This is our little reference theta, right? Our sine is just the y value divided by the radius, or opposite over hypotenuse, however you want to look at it. Cosine would be the x value over the hypotenuse. And tangent is sine over cosine, or y over x. And let's see, to figure out our theta, we're first going to need to find our theta reference. All right, let me pause while I get out my calculator. All right, so one other thing that the problem should have specified, I think, is that we're looking for our angle measure in degrees. I guess it could be either, but so far we've really worked in degrees on this. So we want to make sure that our calculator is in degree mode. You go to mode and change it to degree if it's not already in there. Okay, so in order to undo sine, cosine, or tangent and get that theta out of there, we're going to do the inverse tan, inverse cosine, or inverse sine. And when I look at these, I see, well, tan looks the simplest to me. Remember, we might get different answers when we use sine and cosine, because cosine inverse exists here on this domain from 0 to 180, whereas sine and tangent inverse exists from -90 to 90. So we need to be careful and think about what the answer is that we're getting and what that means. So let's find our reference angle by going second inverse tan of -7 divided by 3. And we get that. Okay, so we're not ever going to say that our reference angle is negative. We're just going to say 66.801 degrees. All right, but that's not actually theta. That's my little reference angle. Now I need to figure out what theta is. I know it's bigger than 270. It's almost 360, but it had to go back 66 degrees. So over here, since that's already negative, I'm just going to add 360. If I add 360 to it, really, it's subtracting. It's already subtracting itself. If you want to do 360 minus 66.8, that's fine as well. All right, so I end up with 200 theta is 293.1. Let's see, it said round to 3 decimal places. So 198. I look at the 5, rounds it up. So 199 degrees. All right, great. So that was a quick review of some of the trig stuff we've done. So here we're looking at the graph below and we're identifying the pertinent information, then writing the equation of the function. All right, so it looks like, ooh, can we even read this? Let's see, if we make it bigger, that looks like a -14, and this is 2, 4, 6, 8, 10. Woo, that's important. Okay, so minimum, negative 14, maximum is 10. So that tells me there's 24 units from the lowest to the highest. If I cut that distance in half, 24, half of 24 is 12, that gives me the amplitude is 12. So I'm going to go 12 up from the minimum, or 12 down from the maximum, and that'll give me my midline. All right, so the midline ends up being y equals negative 2. Okay, cool. So the period here, I want to see, look, we've talked about like temperature and seasons, how, okay, it gets really hot in the summer, and then it comes back to fall, and then winter gets really cold, then it comes back to spring, and we've made one full cycle, one season, like 1 year, we've gone through 1 year of seasons. All right, so then it starts over again, gets hot, then cold, then back to the center. All right, to the midline. So one full cycle here, it looks like, again, it's hard to read, but I think that's 1 pi and 2 pi. So we're going to call that 2 pi. So that's a normal period, the same as the parent function. So the parent function has 2 pi as the period. So what is the equation of the function? So we know, let's write an equation, say f of x is equal to, we've got our midline plus the amplitude times sine. How did I know it was sine? I looked here, it started at the midline, it's positive, starts going positive, sine of, and I have to figure out what goes in here with my x. Okay, so what we did before is we went 360 divided by 360 divided by the period, or 2 pi divided by the period. And the period is 2 pi, so 2 pi over 2 pi is just 1. So that doesn't change at all. The period is just stays the same. All right, let's look at this. So here, let's start at the minimum. All right, 1 full period, let's see, this is 1 pi over 3, 2 pi over 3. So 1 pi over 3, this would be 1 pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. That looks like that reduces to pi over 2. So I see that we've made one full cycle in pi over 2 radians. All right, the amplitude here from -1 to 0, -1 to -2, amplitude is 1. Equation of the midline, -1. The max is 0, the min is -2. Okay, so writing this equation, we're going to use our midline and amplitude, so f of x equals our midline plus the amplitude is just 1. I know that this is cosine, so I actually don't want a plus sign. So I know it's cosine, but also it got reflected, right? It started at the lowest point, so it's a -1 cosine of something. We got to figure out what to put in here. So we're going to go 2 pi divided by the period, pi over 2. So 2 pi times the reciprocal. That cancels, and I get 4. So we are going to put a 4 in here. All right, great. This also tells me that in 2 pi radians, there are going to be 4 full cycles, which is kind of neat. All right. Okay, I think we have 1, 2, 3, 4 more problems, and that is it. So these 4 problems are helping us to solve rational functions, solve rational equations. So let's do that. All right, solve the following equation. Now, we need to be careful. Here it's saying check for extraneous solutions. But before we even start, let's look and say, well, x is not allowed to equal what value? If we look here, x minus 2 cannot equal 0. If I add 2, x cannot equal 2. So that gives us our restriction when we set that denominator equal to 0. So if we want to clear out that denominator, we're going to need to multiply both sides by x minus 2. Right, so I'm taking this side, multiplying it by x minus 2, and I'm going to take this whole side, and I'll do it in a different color just so we can see, times x minus 2. Now, be careful when you multiply something something to a binomial, that x minus 2 gets distributed to both, right? So here it gets canceled out, and I have some students who feel like, oh, it's gone, but it really distributed to both before it got canceled out. Okay, so it goes here, goes there, the x minus 2 came here. That's what canceled out, not the outer one. Okay, so what's left is 7 times x minus 2 plus 10, right, because that canceled out, equals, this whole thing canceled out, 5. All right, I'm going to come over here so we have a little more room. 5 equals 7x minus 14 plus 10. Add these up. 7x minus 4, add 4, divide by 7. All right, so x equals 9/7. That is our solution. If we plug that in, it'll make this a true statement. Okay, what about down here? Here we're looking at the denominator, and I see that we can factor this. It's a very special binomial that is a difference of two perfect squares. So I would like to factor. What times what is x squared? Well, x times x. And what times what gives me -1? A -1 times a +1. And why is there no middle term? Well, -1x and +1x canceled out. And that's just a 3/1. All right. So again, we need to clear out all of the denominators. So in order to do that, we're going to find our LCD, and our LCD is both of these factors. This whole denominator includes that denominator, and really we're saying times 1 on the front, so it technically includes that as well. All right, so we're going to multiply, and here I'm going to write it a little different. We're going to multiply by x minus 1 and x plus 1. We're going to multiply by x minus 1 and x plus 1. Here we're going to multiply by x minus 1 and x plus 1. All right, so I kind of just condensed the step a little. So here it simplifies. Here this whole thing cancels out, and here nothing cancels out. All right, so let's see what's left. We have 4x plus 1. The quantity 4x plus 1 times x minus 1 equals 12 plus, and I'm going to put this back to the way it was when we found it, because that's a simpler form. So I could multiply this all back together, but I'm just going to say 3 times x squared minus 1, because really those things are equal, here and here. Okay, then we can distribute our 3. Here we can just use distributive property. So we get 4x squared minus 4x plus x minus 1. All right, put all our terms together, move everything on the same side. We change color so we can see. Subtract 3x squared. We just get 1x squared. Here we have -4 plus 1, -3, and there's nothing common on that side, so -3x. If I have subtract 12 and add 3, or let's put those together. 12 minus 3 is 9. So we had a 9, but we're going to subtract 9 from both sides. We end up with -10. Wow, okay, it looks like we can factor this. I see 5 times 2 is 10. 5 and 2. Which one has to be negative to make that true? -5 and a +2 add up to -3 and multiply to a -10. So our solutions are x equals -2 and x equals +5. But before I say those are definitely the answers, let's go back and see what are the restricted values. What are the values that I know this equation can never equal? X is not going to be allowed to equal a +1 or a -1. Because those two values would make the denominator 0, and you know what happens when we divide by 0. Very bad things happen. All right, so both of these are equations. Both of these are solutions that work. All right, great. Here are 2 more. I want you to take a minute, try this, and then hit go ahead, hit pause, try them, and then hit play again, and it'll show you all the answers. Okay, thank you for watching the video and studying with me. Um, there will be a couple more days of studying to come. All right, and these were two very simple problems. I think probably the most tricky part is getting that x factored out of this so that you can see, oh, they both have that factor of x minus 1. But then, gosh, we barely have any work to do after we simplify that out. All right, make sure that you're identifying your restrictions. Thank you for watching my video. All right,